Hello, this is Professor Urbis White. Today we will talk about how to solve exponential equations. And we are going to use properties of exponents doing that. Okay, here's the first level. Let's say someone's asking you, solve 2 to the x equals 2 to the third. I know from the theorem that if the bases work, they match, that means the exponents have to match. And this one is intuitive. 2's match. That means x has to be 3. And you can also actually go and check it if you want. If I put 3 to the third is equals to the third. Easy enough. Here's another question. Solve 2 to the x minus 1 equals to the third. If the bases match, that means the exponents have to match. X minus 1 equals 3. Add 1. That means x equals 4. Here's the answer. And here was the answer before. Okay. Easy enough. Something a little bit harder. Now I'm looking at it. All right. 8. First thing you look at, can I make a match? All right. So 2, I cannot do anything about it. It's already prime number. But 8 is 2 to the third power. 2 times 2 is 4 times 2. That's 8. So leave the left-hand side alone. And this one is, instead of 8, I'm going to put 2 to the third. All right. Now I'm going to play with the right-hand side a little bit. When you have exponent of an exponent, what was that property? Oh, I remember. I multiply it out. 2 times 3 is 6x. 3 times 1, that's 3. And watch. Now my bases match. What does that mean? The exponents have to match as well. X plus 1, 6x plus 3. Let's do our thing. So let's subtract x. You have 5x plus 3 equals 1. And subtract 3. 5x equals negative 2. Divide both sides by 5. You end up with x equals negative 2/5. When you do exponential equations, it's not all that important to check, but when you do logarithmic equations, you have to check because there are some extraneous solutions. So this is something that's like, oh, what do I do? You try to find a common base for these two bases. One way, if you don't see it right away, do prime factorization. Okay, 16 divided by 2 is 8. 8 divided by 2, 4. 2. All right, so 16 is simply 1, 2, 3, 4 to the fourth power. All right, let's prime factor 64 as well. 2 and 32. 2 and 16. 2 and 8. 2 and 4. 2 and 2. All right, now let's go count. 64 is 1, 2, 3, 4, 5, 6 to the sixth power. All right, and this one was 1, 2, 3, 4. Now that we found a common base, now I'm going to write, instead of 16, I'm going to put 2 to the fourth to the 3x minus 1. And here I'm going to put 2 to the sixth to the x plus 5. Before I start solving exponent of an exponent, what does that mean? You have to multiply them. 2 to the 3 times 4, 12 minus 4. 2 to the, multiply it out, 6x plus 30. Now bases match. That means the exponents have to match. So let's write down the equation. 12x minus 4 is 6x plus 30. Now let's do it. Let's subtract 6. you have 6x minus 4 equals 30. 6x equals 34. And x equals 34 over 6. All right, let's go and divide that. That's 17 over 3. All right, that's kind of interesting. So you can also go and check that out. All right, now what happens when the bases don't match and you cannot make a match? All right, here's a 2, here's a prime, here's a 5, that's a prime. There's no way I can break them down and make them have a common base. This is what you do. Take ln of both sides. You can also do that with log, L-O-G. Watch. ln 2x, ln 5. Now use your logarithm properties. X comes in front. X times ln of 2 equals ln of 5. ln of 2 is actually a number. So when you have something x times a number equals something else, what are you supposed to do? Divide by that number. Then you get x equals ln of 5 over ln of 2. Very good. We can actually do it a little bit harder. Let's look at this. I'm going to break this down, or you don't have to break it down, but let's do it without breaking it down. 4 and 3, there's no way they can match. So I'm going to take ln of both sides. ln of 4 to the x. ln of 3, 3 plus 2x. What does that mean? You can carry the x up front. X times ln of 4. You can put that 3 plus 2x up front. 3 plus 2x times ln of 3. Let's open this up. That means 3 times ln of 3 plus 2 times ln of 3 times x. Watch. This one has x in it. This one has x in it. So let's move them to the same side. X ln of 4 minus 2 ln of 3x. Let's factor x out. ln of 4 minus 2 ln of 3. That's the left-hand side. Okay, what do I have at the right-hand side? Right-hand side, I simply have that 3 ln of 3. And when I want to solve for x, what do? This is a number after all. That means I divide both sides by that number. So you have 3 ln of 3 divided by ln of 4 minus 2 ln of 3. You see it? Nevertheless, that's a number. You can just plug it into your calculator and get the answer.